In this lesson, we're going to take a look at the relationship between mass and mole. So we learned in a previous lesson that the mole, or 1 mole, is 6.02 times 10 to the 23 of something. And we also learned that the molar mass is the mass in grams per 1 mole of something. So to convert between mass and moles, we have a formula that we can use, which is m is equal to n times m. So n is the number of moles, lowercase m is a mass in grams, and capital M is the molar mass, which is the mass in grams per 1 mole of a substance. So what is the mass of 1.33 moles of titanium? So mass, moles, number of moles is n, which is 1.33. We are looking for the mass, which is lowercase m, and we can look up the molar mass using the periodic table. So when I look up titanium, titanium's atomic mass is 47.87. So that is how many grams are in 1 mole of titanium atoms. So mass then is equal to my number of moles times my molar mass. So 1.33 moles times 47.87 grams per mole. And that is equal to 63.7, and I have moles and then per mole there, so those are going to cancel grams. So the mass of 1.33 moles of titanium is equal to 63.7 grams. What is the mass of 2.55 times 10 to the 23 atoms of lead? So I'm looking for mass, and I have a certain number of atoms, which this I can convert to a number of moles. And once I have my number of moles, I can look up the molar mass of lead, which is 207.2 grams per mole. So I need my number of moles here. So I need to figure out how many units of 6.02 times 10 to the 23 are in 2.55 times 10 to the 23. So that's how many atoms of lead I have. Every 6.02 times 10 to the 23 atoms is equal to 1 mole. So when I do that division, I'm going to get 0.424 moles. So that means my n, or my number of moles, is 0.424 moles. So 2.55 times 10 to the 23 atoms of lead is equal to 0.424 moles of lead, and my mass is equal to, once again, number of moles times molar mass, which is 0.424 moles times 207.2 grams per mole. The moles will cancel, leaving me with grams. And that is equal to 87.9 grams. How many oxygen atoms are present in 0.470 grams of oxygen gas? So that is equal to a mass. How many oxygen atoms? So we want a number of atoms. That I can figure out if I know how many moles I have. So that means that I need to calculate my number of moles, and I can use my molar mass. So oxygen gas is O2, which means that I have 2 atoms, or every 2 moles of oxygen. So my molar mass for oxygen, O2, is 32.0 grams per mole. So 1 mole of oxygen atoms would be 16 grams per mole, but each molecule of the element oxygen has 2 atoms in it. So I need to multiply by 2 here. So if mass is equal to number of moles times molar mass, I want to move the molar mass over to solve for N. So right now I am multiplying by molar mass. So to move that over, I would need to divide. So my mass divided by molar mass is equal to my number of moles. So N equals 0.470 grams divided by 32.00 grams per mole. And I have here moles is in the bottom of the fraction already in the numerator, so that is going to move it up to the denominator. So I have 0.470 divided by 32.00, and that gives me 0.0147 moles. So that is how many moles of O2 I have. I can calculate how many molecules of oxygen that is. So every mole of something is 6.02 times 10 to the 23. I have 0.0147 moles. So I can multiply that by 6.02 times 10 to the 23. And that is going to tell me that I have 8.8, let's see, 3 numbers, 8.85 times 10 to the 21 molecules of oxygen. But each molecule of oxygen has 2 atoms of oxygen, and we're being asked for the number of atoms here, not the number of molecules. So I then need to multiply that by 2, which is going to give me 1.77 times 10 to the 22 atoms of oxygen in 0.470 grams of oxygen gas.